Let's explore the ICMP Protocol, which stands for Internet Control Message Protocol. It is a crucial component for network diagnostics and error reporting. This protocol helps in identifying and reporting network issues, ensuring smooth data delivery across the Internet. It is useful for checking network connectivity and diagnosing any issues that might arise. So, what exactly is ICMP? Firstly, ICMP is a Layer 3 protocol, operating at the network layer of the TCP/IP model. Its primary function is for network diagnostics and error reporting. Specifically, it reports problems associated with IP packet delivery, such as when a destination is unreachable or a packet's time to live has expired. ICMP enables network devices like routers and hosts to communicate control and error information, ensuring network stability and efficient troubleshooting. ICMP serves several important purposes. One key function is error reporting, where it notifies source hosts about problems encountered during packet delivery. This includes issues such as unreachable destinations or when the time to live value expires. It also plays a role in network diagnostics. ICMP provides tools like ping and traceroute, which help network administrators troubleshoot connectivity issues and measure latency. Additionally, it assists in Path Maximum Transmission Unit, or MTU, discovery. This helps determine the largest packet size that can be transmitted along a network path without fragmentation, optimizing network performance. Finally, ICMP can handle flow control, allowing routers to send source quench messages to slow down transmission when congestion occurs, although this is less common in modern networks. Let's examine the structure of an ICMP message. The ICMP header consists of several key fields. First is the type field, which is 8 bits long and identifies the ICMP message type, such as echo reply or echo request. Next, the code field, also 8 bits long, provides additional information about the message type. Following this, the checksum field, 16 bits in length, serves as an error detection mechanism to ensure message integrity. Lastly, there is the rest of header field, which spans 32 bits. The contents of this field vary based on the message type and code. Beyond the header, the ICMP message includes a data section of variable length, which carries additional information or data related to the ICMP message. Here are some common ICMP message types that you'll often encounter. First, there's the echo request and reply, identified by types 8 and 0 respectively. These are used by the ping utility to verify connectivity between hosts. A source sends an echo request and expects an echo reply in return. Then there is destination unreachable, which is type 3, indicating that a packet could not be delivered to its destination, with different codes specifying the reason, such as network or host unreachable. The time exceeded message, type 11, is sent when a packet's time to live expires during transit and is used by Traceroute to map network paths. Lastly, the redirect message, type 5, is sent by a router to inform a host of a better route to reach a destination, helping to optimize routing paths within a network. ICMP is fundamental to several network diagnostic tools. One of the most well-known is ping, which uses ICMP echo request and echo reply messages to verify connectivity and measure round-trip time between hosts. For example, you can use the command ping google.com to check your connection to Google. Another essential tool is Traceroute, which maps the network path to a destination. It sends packets with incrementing time to live values, triggering ICMP time exceeded messages from routers along the path. The command traceroute.google.com will show you the route your data takes to reach Google's servers. While ICMP is vital for network operations, it also presents several security risks. Attackers can use ping sweeps and traceroute to perform network reconnaissance, mapping network topology and discovering active hosts. Another risk is the ping flood, a type of denial of service attack, where a target is overwhelmed with ICMP echo requests to consume bandwidth and processing resources. Additionally, malicious ICMP redirect messages can be used to manipulate routing tables, potentially redirecting traffic to malicious destinations. To mitigate these risks, several security measures can be implemented. Firewalls should be configured to block or rate limit specific ICMP message types at network boundaries. ICMP rate limiting can be implemented to prevent denial of service attacks while maintaining necessary functionality. Network monitoring is also crucial, allowing for the detection of anomalies that might indicate reconnaissance or attacks. Finally, disabling unnecessary message types, such as ICMP redirects, on critical infrastructure can reduce the attack surface. Let's summarize the key points about the ICMP protocol. First, ICMP is a network layer protocol that provides error reporting and diagnostic functions for IP networks. It's not used for regular data transmission, but rather for control and informational purposes. Common ICMP message types include echo request and reply, destination unreachable, time exceeded, and redirect messages, each serving specific diagnostic or error reporting roles. ICMP enables essential network troubleshooting tools like ping and traceroute, which help diagnose connectivity issues and map network paths. Lastly, while critical for network operations, ICMP can pose security risks and should be properly filtered at network boundaries to prevent abuse. For further learning, refer to RFC 792, the original ICMP specification. Use Wireshark, a network protocol analyzer, for capturing and examining ICMP packets. Also, consult the IANA ICMP parameters, the official registry of ICMP message types and codes. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.